All of this is going to bring us back to our original phenomenon. When we observe galaxies in the night sky, we observe that most of them are redshifted. What does it mean to be redshifted? Well, we look at all these many different galaxies in the night sky, and we see that they are emitting this red light instead of a blue light. The reason it's emitting a red light is because it's actually moving away from us. So it's like you're spotting something. If you were to look at a kid in the distance and that kid is running away from you, you'll notice that it's getting smaller over time. If that kid was running towards you, over time, you notice it's getting bigger. So we notice instead of an equal amount of both of these things, it's instead shifting away. Almost every single galaxy in the night sky is moving away from us. And over here, very few of them are moving towards us. What does that mean? What does that mean about what's going to happen in the future? If right now we look at them and they're all moving away from us, what will the universe look like in the future? The answer to that is that the universe is going to expand. It's going to get bigger and bigger and bigger in the future. Well, what would then happen in the past? If we rewind the clock, if they're all getting further away from us in the future, if we rewind the clock, all the galaxies should instead start to come together. And this is how we learned about the origins of the universe. What happened in the very beginning? Well, we think that if we rewind the clock to about 14, somewhere between 13 and 14 billion years ago, that was the beginning of everything. And maybe you've heard this phrase before. It's called the Big Bang. So the Big Bang is essentially the birth of the universe. Everything started at all the mass that you're used to right now, galaxies, planets, stars, all the stuff that made up that was created here in the Big Bang. Before this, there was nothing because time was invented. Time was created during this too. So it was the beginning of space and it was the beginning of time. And oftentimes we refer to them as in the same breath as just space time. So right around here, every single thing was created. Again, we know this because when we go back in time and we were looking at all those galaxies moving away, if we rewind the clock, they all come together. It's impossibly hot and impossibly small when you go back far enough. And that's the timeline that we came up with. Now, the name Big Bang is funny because a scientist who was first hearing this theory was actually making fun of it. And he was like, well, so we were all creating some kind of a Big Bang. And that's the name that stuck. So I guess joke was on him. As we go forward into the future, about 10 billion years ago, we think that this is when the majority of galaxy formation was taking place. So maybe this could be the birthplace of the original Milky Way that's going on. Remember, that's our galaxy. As we go further in time, about 4.6 billion years ago, we have our star that's forming, and same around the same time, we have planet Earth forming right over there. And then we have a notable event, first life, right over there, microscopic. We get dinosaurs right around here, and not too far away from first humans. If it's arguably this time, some people debate that, but let's say it was about 2 million years ago, the earliest forms of humans, right there. Not that far away from there, really far in our time, but in the grand scheme of things, in the entire timeline of the universe, very tiny indeed. So let's define our terms a little bit. If we were to have a correspondence, a buddy, a pen pal with aliens, and we were trying to say, okay, send us a letter, and I'm going to give you our address. But instead of giving you just a regular address, I'm going to give you the cosmic address. We're going to start with saying, okay, well, obviously we all exist in the universe, right over here. And inside of that universe, there is a local supercluster of galaxies. And inside of that local supercluster, there's the local group of galaxies. There's about 3 of them, and we're the biggest one in that one, called the Milky Way galaxy. And inside of the Milky Way galaxy, which is composed of hundreds of billions of stars, maybe even trillions of stars, we're just one of them. That's our star, the solar system. And if we zoom in, the third planet from the sun right there is Earth. And then you can keep going from there. You're going to have to find the continent of North America. And then you're going to need to find the United States. And you're going to need to find New Jersey. And you're going to need to zoom into New Jersey, into Bergen County. And you're going to have to find Old Japan. And then, of course, it will get down to your particular street and house number right there. And then the aliens can talk to you. So that is your cosmic address right there. And you see that we start with the universe. The universe is everything that we know to exist. Every single thing is in there. This is the largest, and we keep continually getting smaller. I typically go from universe down to galaxy to the solar system to the planet. So, how do we discover all this stuff? We were talking about red shifting and blue shifting. How do we discover this? Well, we owe a lot to this astronomer, Galileo. Galileo is credited with inventing the telescope. And when we look up into the telescope, into the night sky, we observe some very interesting things. Now, the telescope is actually pretty limited. We can't see everything that's up there. So, we've actually built a bigger telescope and we put it into space. And that's called the Hubble Space Telescope right over here. It's arguably one of the most important scientific inventions of all time. It's about the size of a school bus, and more scientific papers have been written based on the data that was extracted from the Hubble Space Telescope than any other thing we've ever created. So, very, very important, historically speaking. And I want to tell you a little story about what it was able to do. On September 3rd, in 2003, the Hubble Space Telescope began pointing its camera at a small area in the night sky. So, this area, which was around the tenth of the size of the full moon, appeared to be complete blackness with no stars visible to the naked eye. Now, just to backtrack a little bit, if you were to use the Hubble Space Telescope, you need to actually write a proposal and say, here's what I hope to learn with it, this is what I expect to learn, and this is what I'd like to do. So if you're going to stare at a certain galaxy or a certain star, they might say, okay, sure, that makes sense, blah, blah, blah. But when they did this, there was nothing there, right? It was a big risk. They kept the camera pointed there for over 4 months, taking in all the light that it could. And this is what the Hubble wound up seeing. This right over here. So what do you think we're looking at right there? If it looks like a bunch of stars, I wouldn't blame you for thinking that, but it's actually not. It's a little bit more complex than that. In fact, every single dot in there is an entire galaxy. Each galaxy could contain up to 1 trillion stars each. And each one of those stars could potentially have its own system of planets. And there's over 10,000 galaxies in this one photo. And so 1.3 billion light years away, we're looking at incredibly large distances, some of the early forming galaxies. And what I just find it so crazy is it looks like absolutely nothing from the naked eye. And inside of that, we see that there's all of this. And when you extrapolate that over the entire night sky, we calculate that there could be up to, trillions of galaxies that are out there. And then that just tells you how many potential stars and planets are within there. So there's a lot of space out there, and some people like to say, well, are we alone in space? And if you calculate all the different planets and the stars and the galaxies, if we're the only ones out there, boy, it's an awful waste of space, isn't it?